Hi, welcome to a new course. Let's get introduced to a new programming language, C++. Before we dive into C++, let's understand some basics of programming. A high-level language is a type of English-like programming language designed to be more intuitive and more manageable for humans to understand and use compared to low-level languages. So, what's a programming language? Similar to how humans communicate, a language is necessary for a human to communicate with a computer. Machine language, also known as machine code, is the lowest-level programming language. It consists of binary instructions, strings of zeros and ones, that a computer's central processing unit, CPU, can understand and execute directly. A compiler translates the entire source code into a machine code file. Source code is a program written in a high-level programming language. In essence, a compiler translates instructions from a language we understand into a language that the computer can comprehend. C++ is a high-level and high-performance programming language used for building software, games, and applications. It is a compiled language. It was created by Bjarne Stroustrup in the 1980s. It's widely used in industries like gaming, robotics, and finance. Why do we need C++? It's a powerful language for beginners and advanced developers. It teaches foundational programming concepts. It is used in creating high-speed applications. It's considered a stepping stone to learning other programming languages. Let's get started with setting up. There are two primary ways to do this. The first one would be installing an integrated development environment, also known as IDE. For C++, either CodeBlocks or Visual Studio works. Just install the exe file and follow the instructions on the screen. Another way would be to install Visual Studio Code. It is a lightweight cross-platform. You can use it for many other programming languages just by installing an extension. For C++, we install the C++ extension and its compiler extension. Familiarize yourself with whichever platform you use, and we can get on to writing our first program. Open a CPP file and try executing this code. Don't worry about what it says for a while. Just make sure it prints out Hello World to your screen. Now that it runs, let's understand how the program works. The first statement, include IOStream, is used to instruct the compiler to include the IOStream library, which is a bunch of predefined code that supports input and output from the console. The second statement, using namespace standard, instructs the compiler to use the standard namespace within the IOStream library. The third statement, int main, is where the function or program we want to execute starts. Statements inside these braces will be executed, and since it is a C++ main function, all the statements must end with a semicolon. The part of the statement cout instructs that the text following should be printed to the console. The string within the quotation marks is the string that's printed on the console. The end L stands for endline, where it serves a similar function as using enter in Word. Finally, the return statement exits the function. It's good practice to include a return statement even if there's nothing to return, like in this case, we write return 0. Variables in C++ are sections of memory that are labeled and reserved to hold certain types of data. They act as containers that you use to create, manipulate, and store data. To create a variable, you start off with a declaration. You declare an empty variable of a certain data type with a name. Inside this variable, there will be random/garbage data unless you initialize the variable. You can also declare and initialize a variable at the same time. When creating variables, you want to define their data type. Data types determine what data can be stored in a variable and how the data can be read and manipulated. Common data types are int, float, double, char, and bool. The int or integer data type is intended for whole numbers. The float and double data types are for decimals. Float is precise up to 7 decimal digits. Double is precise up to 15 digits. The char or character data type is for single characters. The bool or Boolean data type is for true and false values. Here are some common data types and their initialization. Take a careful look at their syntax. Whenever you want to convert the data type of a variable from one type to another, we use type conversion. For example, when you want to convert an integer to a decimal number, there are two ways to do this. The first one would be to do an explicit conversion, which is an explicit instruction to change the type, also known as typecasting. Look at the example of converting the type of pi from decimal to int. The second way to do it would be an implicit conversion, which is an automatic conversion. Look at the example of x and y here. In implicit conversion, an automatic conversion takes place. It often occurs when initializing a variable with data using a variable of a type that holds less data. An example is when a double receives data from an integer, it promotes the integer data to become a double. In explicit conversion, an explicit instruction to change type or type casting is performed. Implicit conversion does not occur in reverse. To store a double in an integer variable, you have to convert the double explicitly. Explicit conversion is done by type casting. Here's the type casting syntax. Operators are used to perform operations on variables and values. Arithmetic operators are used to perform common mathematical operations. We have addition, subtraction, multiplication, division, and modulus for integers only. Relational/comparison operators are used to compare two values or variables. This is important in programming because it helps us find answers and make decisions. We have less than, greater than, less than or equal to, greater than or equal to, and not equal to operators. Logical operators are used to determine the logic between variables or values. We have logical and, logical or, and logical not. Finally, we have the assignment operators, which are used to assign values to variables. We have the usual equal to, add and assign, subtract and assign, multiply and assign, divide and assign, and modulus and assign. Expressions are a combination of variables, constants, and operators that produce a value. Example 1. If A is 3.14 and B is 2.71, calculate the sum of A and B. Float A equals 3.14, B equals 2.71. Float C equals A plus B, which gives us a value of 5.85. Example 2. Relational expression is an expression that evaluates to a Boolean value, true or false. If A is 3.14, B is 2.71, then the statement bool result equals A greater than B gives us the result true, since A is greater than B. Example 3. Typecasting in expression. Typecasting in C++ is often used when you need to convert a variable from one type to another explicitly, or when implicit type conversion doesn't meet the requirements of your program. Look at the example here to understand it better. That's all for this lesson. I'll see you in the next one.